Right now, about 40 times a second, somewhere on Earth, a cloud throws a 4-mile spark at the ground. That comes to roughly 3 million a day. We have filmed it at a million frames a second. We have fired rockets into storms to yank bolts down on command. We have built a radio telescope to watch a single bolt grow in 3 dimensions, branch by branch, like a tree that grows in a tenth of a second. We have, in short, studied lightning so hard that one of the ways we study it is shooting rockets at the sky to make it angry. And after all that, here is the part nobody admits at a dinner party. We do not actually know how the spark starts. Not the bolt. The bolt we understand. The first spark, the match. Because to rip a spark through air, you need a serious electric field, about 3 million volts across every meter. So people floated instruments straight up into the meanest clouds on the planet to measure the field inside one. And the field inside a thundercloud comes up short. Not a little short, about 10 times too weak. The strongest field anyone has ever recorded inside a storm couldn't light a spark on a calm afternoon in a parking lot. Meanwhile, the storm overhead is firing 3 million a day and not asking anyone's permission. So something up there is starting fires with a match that, by every measurement we own, is soaking wet. The number for breaking down air is not a guess. It's one of the most solid figures in physics. 3 megavolts per meter at sea level. Push harder than that and air stops being an insulator and becomes a wire. Lab people hit it every day. It is the reason a doorknob bites you in winter and the reason a spark plug works. The threshold is not the mystery. The mystery is that the place lightning actually happens never reaches it. You would assume someone just hasn't measured carefully enough. They have. Since the 90s, teams have sent balloons up through active storms. The balloon, the instruments, the whole package, straight into the part of the cloud that's about to fire. Some of those balloons got struck on the way up, which is, scientifically, a great result and a bad afternoon. And the field they recorded right before the strike was about a tenth of what you'd need to light a spark. The cloud fired anyway. The instrument measured a field too weak to do the thing it was, at that exact moment, watching the sky do. This is the whole paradox in one sentence. We have the gun, we have the body, and the gun is not loaded. It has never once been loaded. And yet, so if the cloud can't light its own spark, something has to give it a hand. And the front-running idea for what that something is comes from a place I want you to sit with. Not the cloud, not the storm, not the planet. A different galaxy. Here is the proposal, and it's been kicking around since a Russian physicist named Gurevich floated it. High above the storm, a particle, a cosmic ray, flung out of some dying star or a black hole's bad mood thousands of light years away, comes screaming into the top of the atmosphere at nearly the speed of light. It smashes an air atom and shatters into a spray of electrons. And in the weak field of the thundercloud, those electrons don't just drift. The field can't light a normal spark, but it can lean on a fast enough electron and shove it faster. That electron hits another atom, knocks loose more, those get shoved too. An avalanche, but a relativistic one. Electrons multiplying near light speed. The field that was too weak to start anything turns out to be exactly strong enough to keep a runaway going. Once something hands it a runner. That's the mechanism. The cloud can't strike the match, but it can pour the gasoline. The match comes from the sky. Which means the most local, most ordinary violence we know, the flash that hits the church steeple in your town, the one on every weather icon, may begin with a particle that left another galaxy before there were people here to be afraid of it. The bolt is parochial. The trigger may have a return address in Andromeda. It's a beautiful idea. It is also not proven. The numbers are tight. The avalanche may not be big enough on its own, and plenty of serious people think the real answer is humbler and closer to home. Because the other leading idea doesn't involve the cosmos at all. It involves ice. A thundercloud is a blizzard standing on its end. Billions of ice crystals and soft hail, all churning, all crashing into each other in the updraft. And around the sharp tip of an ice crystal, the field isn't the cloud's weak average. It's concentrated, the way the field around a needle is fiercer than the field around a beach ball. The thinking goes that in those tiny pockets, right at the points and edges of colliding ice, the field briefly spikes high enough to light a microscopic spark, and a few million of those, in the right place at the right instant, might braid together into the start of a leader. So in one theory, the trigger crosses the universe, and in the other, it's two snowflakes having a disagreement. Physics has narrowed the cause of lightning down to a passing cosmic ray or frost, and is genuinely unsure which, and it might be both, or neither, or something the field hasn't named yet. That is not me being coy, that is the actual state of the field. Here's what stings. We are not helpless in front of this thing. We are, in every other respect, terrifyingly good at it. We can summon lightning. At a research range in Florida, people fire a small rocket trailing a thin copper wire up into a charged storm, and the storm obligingly sends a bolt down the wire to the ground. Lightning on a leash, scheduled, repeatable, on a Tuesday if you like. We can trigger it, we can time it, and we can watch it. There's a radio telescope in the Netherlands, LOFAR, built to listen to the early universe, that turns out to be the best lightning camera ever made. It catches the radio crackle a bolt gives off and reconstructs the whole thing in 3 dimensions, down to about a meter, while it happens. It's so sharp it found structures nobody knew were there, little 100-meter spurs branching off the channel that the textbooks had no name for. They called them needles. So picture the full toolkit. We can call lightning down on command, photograph it at 1,000,000 frames a second, and rebuild it in 3D in the air. We have mapped the bolt's entire life, its branches, its needles, its return stroke, its death. We have everything except the one frame where it begins. The camera is always rolling, the resolution is a meter, and the first event still happens just under the floor of what we can see, which is the quietly unnerving part, and the reason this whole problem refuses to die. Lightning is not exotic. It is the single most familiar violence in the sky, the thing on every forecast in every storm you've slept through, the oldest light a human ever flinched at. We put it on warning labels, we named a car after it, and the moment it actually begins, the first spark, the match strike, time 0, has never been measured by anyone, because the field where it happens is, by every reading we have ever taken, too weak to start it. 3 million times a day, the sky does a thing that our physics says it cannot do. We've watched the whole life of the Flash. We just have never seen it born.